So, welcome to Math-Tinik. So, our topic is still general solution to particular solution. So, we have the example number 7. So, we have 1 over y dy over dx equals to tangent x. When y of pi is equals to pi, and we have a given answer, which is y is equals to negative pi secant x. So first, I'll just transpose dx to the other side. I'll just cross multiply it, so we will have 1 over y 1 over y dy is equal to tangent x dx. Then we will have uh we can now integrate both sides, so we will have integral of both sides, so we will have integral of dy over y. So integral of dy over y is equivalent to ln of y is equal to integral of tangent x. We know that tangent x is also equivalent to sine x over cosine x. So I'll just change tangent x with this. So we will have integral of sine x over cosine x dx. Now I will now use u substitution. So I will let u is equivalent to cosine x. So taking the derivative, so we will have du is equals to negative sine x dx. As you can see, we have negative sine x dx. But in our differential equation, in our problem, we only have sine x dx on the numerator. So I'll divide both sides by negative 1. So we will have we will have negative du is equal to sine x dx. Then I'll substitute our use to in our x in our x variables. So we will have ln of y is equal to integral of our sine x dx is equivalent to negative du all over cosine x. Our cosine x is equivalent to u. So we will have integral of negative du over u. So the integral of negative du over u is equivalent also to ln of u plus c. Sorry, I forgot the negative sign here. We have negative sign. So it's equal to ln of y. As you can see, we have negative. So I can put negative in the exponent of u. We will use the property of natural logarithm. So we will have, so I'll transpose negative into here to become the exponent. So we will have ln of y is equal to ln of u raised to negative 1. So u raised to negative 1 is equivalent to 1 over u. 1 over u plus c. And then, I'll just take the exponential of both sides. So we will have y is equal to e to the ln of 1 over u plus c. This is also equivalent to exponential of ln of 1 over u times exponential of c raised to c. So as we know, this one is equivalent also to c. So now we will have c multiplied by 1 over u. Now our u is equivalent to this cosine of x. So I will just substitute it. So we will have, so our equation will become y is equal to c times 1 over u. So 1 over cosine x. And then now we will substitute our given initial conditions. So our initial conditions are the following. Y of pi is equal to pi. So I'll substitute for I'll substitute this one for x, and then I'll substitute this one for y. So we will have pi is equal to c times 1 over cosine of pi. We know that cosine of pi is equivalent of cosine of pi is equivalent to negative 1. So we will have pi is equal to c times negative 1. So dividing both sides by negative 1, so we will have negative pi is equal to c. So we will have we will back to this one, to this equation. And now we will have y is equal to the value of c, which is negative pi, multiply by 1 over cosine x. We know that we know that 1 over cosine x is equivalent to secant x. So I'll just transform this one into y is equal to negative pi times 1 over cosine x, which is equivalent also to secant x. So that's our answer. So now let's go to the more difficult one. I'll just change my ink. Okay. So we are given that 1 over y dy over dx equals to x times e raised to x with initial conditions that y of 2 is equals to 1. So first, this we will substitute this one for x. We will substitute this one for y after we integrate all of our equation, or our differential equation. So now I'll cross multiply dx to the other side, then I will retain dy from this side. So we will have dy over y is equal to x e to the x dx. So as you can see, we can now both integrate both sides. Integrating both sides, we know that integral of dy over y is equivalent to ln of y is equal to integral of this. So in this case, we will use integration by parts. Integration by parts. We know that uv minus integral of v du is equivalent to u integral of u dv. So in this case, integrating x e to the x dx, so we will let u is equivalent to x, and then the derivative of that will become dx, then taking the dv, so taking the dv1 is here, is this part, uh, is what, this part, which is e to the x dx. So we will have e to the x dx. So integrating both sides, we will have e to the x, e to the x. And then we will now go to this formula. So we will have u times b. So it is going to be x times e to the x minus integral of b times du. So we will have e to the x dx. So integrating further, we will have x e to the x minus integral of e to the x dx is equivalent to e to the x. So now we will now substitute this one. So this one is equivalent to x e to the x dx. So now we will substitute here now this one into here. So we will have x e to the x minus e to the x plus c. And now, we will substitute our given initial conditions that y of 2 is equivalent to is equal to 1. So we will substitute this one for x, and then we will substitute this one for y. So now we will have ln of 1 is equal to, which is the value of x is 2, then the value of e to the e to the e, and then we will have raised to 2 minus e raised to the power of 2 plus c. We know that ln1, so ln of 1 is equivalent to 0. So we will have 0 is equal to 2e raised to 2 minus e raised to 2 plus c. So simplifying these terms, so we will have 2e raised to 2 minus e raised to 2, we will have e raised to 2 plus c. Solving for c, we will have c is equivalent to negative e raised to 2. So that's the value of c. Now we will substitute this one into here. So now we will have, by substituting, we will have ln of y is equal to x e to the x minus e to the x minus e to the second power. So that's our answer. So simplifying further, so we will have, by factoring e to the x on these two terms, we will have e to the x quantity x minus 1 minus e to the second power. So that's our answer. Thank you, Kamatinik, and then I will see you on my next